Okay, lesson 18. I got one of my heroes right here, The Rock. If you don't watch WWE wrestling or never have before, this guy's a legend. I know you guys probably know him as an actor in all his movies, but when he was a wrestler, he was a legend. So, anyways, for the lesson 17 homework, all I asked you to do was get on your calculator, start messing around with the A, B's, and C values of these things to see what it does to the graph. Now I'm going to actually talk specifically about just the A value today and go from there. So let's talk about what these things are. This A value has a name. It's called the amplitude of the graph. All right, that's a word that you should know for graphing sine and cosine. It's called the amplitude. We'll refer to that often as the stretch of the graph. So what you should have noticed is when you change this A value to a larger number, your graph gets stretched taller. That's called the amplitude changing of the graph. I'm going to get into that with you here in just a couple of minutes. All right, we're going to talk in lesson 19 about this C value right here. We'll get to that. And then in lesson 20, I'll show you the B value. The B value is probably the trickiest one of all of them. If you noticed anything when you changed your B value, what you should have seen is more curves on your screen than what you saw originally. The C value, you should have seen your graphs slide up or down and shift themselves. All right, those are things that we've been talking about throughout the year as far as shifting graphs up and down. The A value, putting a number out in front, we've called a dilation before, also called a stretch. I'm going to focus only on that today, the A value, talk to you about how that works, and then I'm going to give you a couple questions that I'd like you to graph. I know you don't have graph paper, just sketch them out on paper, that's fine, that's what I'm doing up here. Not paper, but whiteboard. All right, so let me give you my first example of a question where I'm changing the A value. All right, so the first one I'm going to do here is I'm going to take y equals 3 cosine x. So I've changed the A value to 3. So this graph's going to have what we call an amplitude of 3. That's a stretch. So I'm going to put up the original graph of just cosine x first, do some erasing and manipulate it and show you what this 3 does to this graph. You probably saw it on your calculator if you did any of the work I asked you to do on your homework. So when we graph these, for now, we're only going to graph them out to 360 and over to negative 360, which in radians is 2 pi to negative 2 pi. All right, we're going to change that when we start messing around with the B value. Told you that's going to be a little tricky. We'll get to that in lesson 20. All right, so for now, we're just going to continue to go by increments of pi over 2 or 90 degrees. So pi over 2, pi, 3 pi over 2, and 2 pi. And then on the negative side, same thing. Probably should adjust this a little bit. There we go, negative 2 pi. Now remember, in degrees, this is 90, 180, 270, 360, but we switched them to radians because graphing is done in radians with trig graphs. So what is cosine? Just cosine x without the 3. So let's imagine the 3 is not even here for right now. We graphed cosine in lesson 17. I showed you that. We went around the unit circle. I showed you how that graph develops and forms. It looks like this. And on the negative side, it looks like that. All right. And again, this graph was formed just by going around the unit circle. For example, knowing that at 90 degrees or pi over 2, it's 0. At pi, it's negative 1. 3 pi over 2, which is 270, it's back to 0, and so on. That's where this graph came from. So what does the 3 do? The 3 is a dilation or a stretch. It's going to take this graph and it's going to stretch it up to 3 and down to negative 3. Now, it's not going to move it up 3 spaces. It's just going to stretch or dilate it by 3. So what's going to happen is basically all of your y values get multiplied by 3. And that's something we talked about back when we were in school in good old room 227. That when you put a number out in front of a function, it multiplies the y values by that number. So the reason I'm pointing that out is because all of these values right here where y is equal to 0 aren't going to change, because when you take 0 and multiply it by 3, it doesn't move. So those points are going to stay consistent. What's going to change though is instead of this graph going up to 1, it's actually going to go up to 3 now because of this 3 right here. So it's going to peak way up here. And instead of going down to -1, it's actually going to go down to -3. So this part of the graph is going to slide down to -3. This part was at 1, it'll slide up to 3. This one was at -1, it will slide down to -3. This one will go up to 3. Now notice, I'm not moving the graph up 3 units. I'm just stretching it out to 3. All right, so this graph is now going to look like this. Boom. All right. So we have taken this cosine graph and we've stretched it or dilated it by 3. So that's what the 3 out in front will do. Now, if you want to go in and just kind of get rid of the purple because we don't need it anymore, this red that's left is 3 cosine x. So that is what we do when we change the a value. So this graph has what's called an amplitude of 3. All right, it's been stretched to 3 and down to -3. I'm going to show you another one with sine next. All right, so I'm really going to get you on this one. So I've done 2 things. I've put a 2 in front of sine, but I've also thrown a negative on it. All right, I'm doing that in this example so that I don't have to do this example plus one more with a negative. I can combo it, do it all at once. You can get it done, not have to take so long to watch this video. I know that I'm excited, and the rock's here. But other than that, we'll just keep going here. So sine x, let's start with that. Let me sketch a graph of sine x first. Did that in lesson 17. Once again, we got pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Sine, all right, if you go around the unit circle like I did in lesson 17, sine starts here, goes up, comes down, goes down to -1 and finishes back here. And then on the negative side, it does that. So that was something I addressed in lesson 17, just going around the unit circle and grabbing their coordinates. Now, we have a 2 out in front of this sign, but also a negative. Let's go back when we were in room 227. Remember the good old days. What does a negative out in front of the function do to the function? It reflects it over the x-axis, flips it over the x-axis. So this graph is going to get flipped over the x-axis, and then we're going to dilate it by 2. Now, what order you do that in is up to you. You can stretch it to 2 first, then flip it, or you can flip it first, then stretch it. Entirely up to you. I am going to flip it first, then stretch after. So let me do the flip first. And I'm going to do that in orange. All right, so if I take this graph and reflect it over the x-axis, what happens is this piece of it right here is now going to be like that. This part is now going to be up here. This is now here, and that is now here. Now I've dotted that. Can you see that? Yeah, I guess you can see it. I've dotted that because I'm not going to use that. I'm going to erase that here momentarily. So I just dotted it to kind of sketch it in. But now, so that takes care of the negative, but now I need to dilate it by 2. I need to stretch it to 2. So I need to take these dotted lines and stretch them. Now remember, these points that are on the x-axis remain fixed because their y values are 0. So when we stretch 0 by 2, it doesn't do anything. So I now need to just take these points right here, that now is at -1, stretch it down here to -2, stretch this one up to +2, stretch this one down to -2, stretch this one right here up to +2. Ooh, my graph's a little off here, sorry. This should be like that, sorry about that. And then up to 2 here. So my new graph is gonna come down, go back to 0, go back up, down to 0, down to -2, back to 0, back up, and then back down. So that graph has been reflected over the x-axis, stretched to. So what I can do now is get rid of the original black graph. I can get rid of my dotted line. And that right there is the graph of -2 sine x. And you can confirm that on your calculator. I showed you the settings in lesson 17 you can set your calculator to, put it in radians, adjust the window, and you can type in -2 sine x into y equals to confirm that that's what this graph looks like. So for homework, I'm going to have you do a couple of graphs where I'm going to adjust the A value, called the amplitude, and have you just sketch them, and that's all. All right? So give those a try, and I'll put the solutions up as well.